We have started a new standard on congruent triangles, and in this video I'm going to talk about the 5 different triangle congruence theorems. When two triangles are congruent, there are 6 facts that are true about the triangles. The triangles have 3 sets of congruent, and remember congruent means equal. So the triangles have 3 sets of congruent sides, and the triangles have 3 sets of congruent angles. So in this picture, I have 2 congruent triangles. Triangle ABC is congruent to triangle DEF. Notice my triangle congruency statement here. The corresponding congruent sides are marked with small straight lines, segments called hash marks. The corresponding congruent angles are marked with arcs. So these right here are my hash marks, and these are my arcs with the angles. And notice in my triangle congruency statement, I have the corresponding sides matched up with the corresponding angles. That is important when you're writing that part. The first triangle congruency theorem that I'm going to talk about is SSS, side, side, side. If 3 sides of one triangle are congruent to 3 sides of another triangle, the triangles are congruent. You should already be familiar with this because we talked about this when we did similarity. So I have 2 triangles here, triangle ABC and triangle FED. So now let's see why this is SSS. We should have 3 sets of sides that are congruent to each other. So our first set is BC is congruent to FE. Notice that they both have one hashtag or hash mark. Okay? And AB, side AB, is congruent to side ED because they have 2 hash marks. Notice my geometry symbols I'm using here, the congruent symbol, the line segment above my letters. And then AC is congruent to FD. They both have 3 hash marks. So my triangle similarity statement would be triangle ABC is congruent to triangle DEF. And to write that, the first part, ABC, I just picked that. And so if you notice up here, I went from the second hash mark to the first hash mark. So ABC. So I have to do the same thing over here. So the second hash mark to the first one. So it should be DEF, the ordering. And if you have trouble with the writing the triangle congruency statement, you need to talk to me. Alright, the second one I'm going to talk about is SAS, side, angle, side. If 2 sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. Included angle means it's the angle that is in between the 2 sides. So here I have 2 triangles. We have 2 sets of congruent sides. And if you see here, we don't have any angles marked with an arc. However, you should know from your angle relationship standard that we have a set of vertical angles here. So first thing I'm going to take note are my sides here. So side AC is congruent to side CD because they both have 1 hash mark. And then my vertical angle is angle ACB would be congruent to angle DCE. And then my other side is BC is congruent to CE because it has 2 hash marks. Once again, you should recognize the vertical angles here. So since we have the 2 sides and the included angle, our triangle congruency statement is triangle ABC is congruent to triangle DEC. And once again, you have to make sure that the corresponding sides match up and the corresponding angles match up. And for this one, an easy way that I did it is I did ABC. Well, AB is the blank side and BC is the one with 2 hash marks. So I start with the blank side here, DE, and then I go to the 2 hash marks. So DEC. Alright, my next one is ASA, angle side angle. If 2 angles in the included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. So I have these 2 triangles here, and I have some arcs to recognize my congruent angles. So angle A would be congruent to angle F, angle C is congruent to angle E. I have that here. Angle A is congruent to angle F, and then I'm going to put my side here. AC is congruent to FE, and then angle C is congruent to angle E. Notice I didn't have to use 3 letters with my angles because these triangles are separated and it's easy to identify the angles. So triangle ABC is congruent to triangle FDE. I also think when there's angles involved, it's a lot easier with a triangle congruency statement because angle A goes with angle F and angle C goes with angle E. So I think that is a little easier to write this statement. Alright, our next one is angle, angle, side, AAS. If 2 angles in the non-included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. So I have 2 triangles here. Triangle ACB, angle ACB is congruent to angle DCF. Those are my vertical angles that are not marked with an arc. Then I have angle B is congruent to angle F. I don't have to use 3 letters here because it's clear which angles are F and B. And they were already given in my picture. And then side AC is congruent to side CD. And notice my ordering here. The side is not in between those 2 angles that are congruent. It goes side, side, angle, angle, or angle, angle, side. And so my triangle similarity statement is triangle ABC is congruent to triangle DFC. Our last one is HL, or the hypotenuse leg theorem. This theorem only pertains to right triangles only. So if the hypotenuse and leg of one right triangle are congruent to the corresponding parts of another right triangle, the right triangles are congruent. So here I have 2 right triangles. That's critical for this. And I know that AC is congruent to EF. Well, that's my hypotenuse. So we already have the hypotenuse part of it. And then AB is congruent to FD. So now we have the leg. So that's why it's just hypotenuse leg. So triangle ABC is congruent to triangle FDE. And once again, when I named it, I did ABC. So I started with the side with 1 hash mark and then went to the side with no hash mark. So when I'm writing my congruency statement, I started with FD and then I would go to E because it has no hash mark. Methods that do not prove that 2 triangles are congruent. Angle, 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 that only proves that the 2 triangles are similar. So these 2 triangles are similar, but they are not congruent. And then also SSA or ASS, side side angle or angle side side. That is another method that does not work. So when you know 2 triangles are congruent, you can use the theorem CPCTC, corresponding parts of congruent triangles are congruent. So most of these methods or theorems involve showing 3 things. So you don't have to show all 6 things. You just have to show 3 things. And so once you show those 3 things and you show that they're congruent, then because of CPCTC, then the rest of the parts of the congruent triangles will be congruent also. So now I want you to, since you've finished watching this video, I want you to go to my website, and I want you to go to assessments and click on Triangle Congruence Theorems, and I want you to take the assessment. That will tell me whether or not you watch this video. And here are my resources that I used.